Your houseplants are not fragile. They've survived floods, droughts, trees falling on them, and even being eaten alive. What makes us think that they can't handle one missed watering? Hi, my name is Memo, this is my channel, Houseplantygoodness, and essentially it's a place where I like to geek out about my big passion. You might be able to see some of it behind me, it's tropical houseplants. So yes, today is going to be a much requested video over the few months actually, and definitely from the last few videos that I've done where people were saying, can you do a bit more of a deeper dive into evolution of plants? And today I'm going to cover some of the more obvious traits that we see in a lot of our house plants and explain how plants have evolved in order to cope with the chaos that exists a lot of the time in their natural kind of rainforest and tropical environments. And in doing that, I'm going to showcase how these plants have evolved in a way that not only can they survive, but also sometimes thrive, even with the mistakes that we're all going to do with their care invariably. First, let's cover off the most obvious thing. These plants didn't evolve in pots, in mounts, in all of these things. They evolved in essentially what is disturbance on a daily basis. This is the crocodile fern, and I will show you more than just ferns today, but let's start with some fern examples. And the first thing I want to cover is think about tropical rainforest. That's the easiest thing, and that's the thing that most people's brains will go to when they think of tropical environments. Is any of what you're imagining stable? Is it the kind of thing that you'd be sitting there and this is nice and peaceful and nothing happens? The tropical rainforests on most tropical environments tend to be very dynamic. Things are happening every minute of the day, and every minute of the day there is something that could disturb the plants that are living there. They are not and have never been stable ecosystems. That is what makes them unique, and that is what makes them fascinating. It's also, and this is something that sometimes a lot of people fail to make the connection, barring the obvious reasons why there's a lot of house plants that are tropical plants that you would imagine they could survive in household conditions, lower light levels and all of these things, but part of the reasons why so many house plants tend to be tropical is because of their immense amount of adaptation to survive a lot of less than ideal conditions. Because again, what we just talked about now, these environments that they are all growing in are very dynamic. Things change all the time. They need to be adaptable, which makes them perfect in a household where things could happen. Things might fall on it. The pot might fall. The conditions might be less than ideal. You might get a cat munching on things. These things are not something that they've never experienced before, evolutionary at least. Maybe not in exactly the same way that they're experiencing it in our households, but the stressors are very similar when you start thinking about it. So there's always an edict with a lot of plants that are going, give them bright and direct light. Never give them bright light, they will fry. I pose you a question. In a lot of these forests, there are going to be times, say, let me give you a very specific example, which is less rare than you might think. A tree might snap, it might be a lightning strike, it might be age, it might be whatever is causing that tree from the canopy to snap. That then creates an opening within the canopy, at least briefly, until the other trees can start growing in and filling in that space that didn't exist before. And at that point, if this plant was directly underneath where that gap was created within the canopy, guess what this plant is going to be getting for a very long period of time until those trees grow? A lot of bright light. They are adapted to be able to cope with that level of stress, especially if it's going to be short-lived in the grand scheme of things. They're not suddenly going to be in bright, bright light for years on end. And then there's something else that we need to discuss, and somebody very rightly said in one of my previous videos, who is actually one of my viewers from the more tropical regions, that, and it's a very good comment, and it's a thing that a lot of people that are not from the tropical regions of the world don't always make the distinction. There are kind of locations where there is kind of ever wetness essentially, so kind of tropical regions where there is constant moisture, constant humidity and all these things, but there are also tropical regions where they do have really dry and less than kind of wet conditions that we might all be considering it, and that's something that we always forget as well. So it does mean that in some tropical environments there are going to be drought stresses that are going to happen as well. Conversely, if we're talking about the tropical environments that are kind of ever wet, they're going to be dealing with floods a lot of the time. Even the ones that have got drought seasons, that can also cause flooding, because if the actual ground level and everything is very, very dry, it means it's going to absorb a lot less quickly if they suddenly get a flash of rain, basically, which means that flooding will happen. And obviously, I have talked about this ad nauseum, a lot of our plants are going to get munched on by herbivores. There are animals in most of these regions that will want to chew on and eat a lot of these plants. And I'm not just talking about the common pests that we might have indoors. You need to think about bigger things, bigger actual animals that are going to be sitting there and munching on some of these leaves. But let's have a look in more detail about drought adaptation for plants. And I've got two examples here, one being a Hoya and the other being a succulent, or in this case, a cactus. So this is a spiral cactus. This is a Hoya macrophylla, if I'm not mistaken, the variegated form. So plants are used to and they are adapted to dealing with drought. Actually, let me not put down the cactus. Let me bring up the cactus as a first example. So in very simple terms, this plant has not been watered in, we are now first day of March when I'm filming this. This has probably not been watered for at least 6 months at this point, or kind of getting close to 6 months. Yes, it does mean that it is slightly thinner than it would normally be, but have a look. This plant is most definitely not dead. If anything, this plant is dormant at this time of the year, and this is why a lot of the times the edict for some cactuses, maybe not always indoors, but ones that are going to stay maybe in a dry greenhouse outside, they can handle the cold as well sometimes, and some of them, but they can definitely, as long as they stay dry, they are basically dormant and they are waiting for that summer season to start again. But it also means that, remember what I was talking about before, they can handle long periods of zero water. Not talking about small amounts of water, but zero water. And that is part of their adaptation because of their environment, because of where they are growing naturally. You need to think about this sometimes. Like if you think about deserts or desert environments where a lot of the cacti might be coming from, not all cacti, but some of the cacti might be coming from, think about how dry it might be. Yes, you might get some precipitation at night, but it's not as often as you might imagine. What it does also mean is that these plants, a lot of, specifically the cacti and succulents, have developed something called CAM, or crassulacean acid metabolism. It's just an abbreviation, CAM. And that is the adaptation that they have where, in simple terms, what they do is if they are going to be exchanging gases, that is going to happen through them opening the stomata. These are kind of like mouth-like structures within their kind of green surfaces. If they don't have leaves, obviously, it's going to be within the kind of growing part of the plant. And they will open these up to do an exchange of gases that will happen not during the day, which is what most plants will do, most kind of leafy green plants will do, but they will do this at night. The temperatures are lower, the scorching sun isn't there, and even if there isn't moisture in the air, it means that when they're opening the stomata, there is a high chance that there's going to be evaporation of some of that very precious water that they're trying to keep hold of. So they do it at night. They don't do it during the day. It's too risky for them to open the stomatas and do that exchange of gases throughout the day because it's likely that they're also going to lose some of that moisture as well. So they flipped it on its side and just went, you know what, let's just do it at night. Why do we need to do it during the day when it's too risky? That is evolution at its finest. The next thing we need to think about is two things basically in terms of evolution, both kind of waxy leaves or waxy cuticles, and also succulent leaves. So I specifically bought the macrophylla Hoya here, and I could have also, I don't have one anymore, but I could have also bought the Hoya kerrii, the heartleaf Hoya. If you've ever noticed how thick those leaves are, and it doesn't just have to be Hoyas, it could be a lot of our tropical plants. So for example, I'm looking at behind the camera, there is the Syngonium chiapense. It's got very, very thick leaves for a leafy kind of aroid. Same thing goes for monsteras. If you compare them to something as delicate and as fine as ferns, these plants that have got the kind of waxy cuticle and also the thicker leaves, it is there to help maintain some of that moisture and also store that moisture. So if they do have periods of drought, then it means that they do have a backup of moisture within their actual system, cells, leaves, whatever you want to call it, basically, where they can actually go, you know what, I can survive for a tiny bit. And that is something that we also need to be paying attention to, because if they've got thicker leaves, they've got waxy cuticles, all of these things, it tells you, oh, this plant has evolved this way, which means that in its natural habitat, it experiences periods of drought where it needs to survive by utilizing the moisture that's within these structures, or not letting that moisture kind of release because of that waxy cuticle, which then should also tell us, oh, this plant can deal with like a missed watering or two, or even a few, or even I need to let it go dry for a bit longer. It would expect it, and it's more adept to dealing with that than having constant moisture all the time, because the plants have evolved for that stress. They haven't evolved for the opposite. And again, I'm going to harp on about this. Even rainforests do experience droughts or drought periods, more so than you would think, actually. So these plants are evolved to be able to deal with it. And that's why, obviously, extreme example of kind of something that's used to growing in very arid conditions, so think deserts, to something that might be growing in a bit more of a tropical environment, or even tropical rainforests. And again, I'm going to bring it back to, because a lot of people have got epiphytes over the years, especially if they've been growing collections, even if they're downsizing, they probably still have a fair share of epiphytic plants. In nature, those dry out very often, more so than you would imagine. But let's talk about the opposite now. How about flooding and the root oxygen zone, basically? So I don't have, this is time of the year where I don't have a lot of alocasias that look great, but I will put a picture or a video here so you can kind of see an example that I'm talking about here. And I'm using the example of an alocasia, colocasia, any of these kind of more tuberous-like plants, because a lot of people tend to forget that they are not just used to having a lot of water around their roots. A lot of the times these plants are growing marginally, big word, to things like big lakes or rivers and all these things. They want that moisture. They've evolved to be okay with that moisture around their kind of roots. What that also does mean, and this is something that maybe sometimes people don't make the connection with, if you think of a river, if you think of rivers flooding, what does that usually mean? Just in everyday life, like you might be experiencing, you might have rivers near where you live. What happens when those rivers flood? Correct. Those rivers will break their banks, in essence, flood the surrounding region exactly immediately by the river, which means that has a lot more water than it would have had before. And that does take a while for it to recede back into the regular river size, if that makes sense, which means all of those plants around the edges of that river need to be able to deal with flooding on a semi-frequent basis, actually, because if you think about it, again, a lot of tropical environments, that flooding might be happening more than you might expect. And it also explains why a lot of aroids have evolved to survive in floodplains. And I've got I've got one that, again, is not looking great because it's this time of the year, but the Cryptantha, is it the Cryptantha? Cryptantha johnstonii? I'll put a picture or a video here so you can kind of see. And a lot of people struggle with that specific plant because they are not providing it with enough water. Because a lot of the times that plant, in order to be happy, needs to always be sitting in some form of water, at least in the summer in its growing season. And that's where people go wrong and they end up losing those plants, even if they've done really well during the summer, because they keep that water reservoir there in the winter. That's separate because that plant might not be doing anything in the winter, and at that point, having constant moisture isn't going to work for it. Because a lot of times, again, you need to think about what these plants haven't evolved for. Think about the tropical regions. A lot of the times the temperatures might not be fluctuating enough. So yes, can some of these plants go dormant and survive their dormancy in our environment? Yes, winter months kind of a thing. But you also need to think about, do those plants ever in nature go as fully dormant as they would do in our environment? Because again, we've talked about this before, even at their best of times, even in the summer months in our households, depending on how cool we keep our houses in the summertime, that might still not be summer for those plants. It might still be winter for what they're used to in their natural environment. So we need to remember this. So they haven't been evolved. These plants that maybe don't have a true dormancy period in nature aren't evolved to be sitting there in a lot of water because they're not actively growing at that time of the year, where in nature that would never happen. They would constantly have the right temperature, they would constantly be growing. So if they're sitting in some flooded plains, they're okay with it, at least for a certain period of time. Big word alert now, and it's an ancient Greek word, and it's something called aerenchima, and I'll put it up the top here. And it comes from two Greek words, aer, which means air, and enchima, which means infusion. And you need to think about this for a lot of tropical plants that might be aquatic. Because if you think about it, it's just like, well, how is this plant surviving fully in water, underwater? It's because they actually have water infusion within some of its cell structures, basically. I'm not going to go into too much detail, but there is water within the structures of the plant themselves, not water, air. There is air within the structure of the plant itself. Think of them as little air channels within its roots. And then you need to think about things like adventitious roots as well. So for instance, if something else floods down below, if they've got roots higher up where it's not flooded, it means that they can survive that flooding a lot better, because even if everything goes wrong with the roots down below, it has got roots, the adventitious roots, in other places, which means that they can dry out a bit more, and if they need to, they can then at least support the plant for a small period of time so that it can re-establish if everything goes wrong with its roots, that it might be in the ground, it might be flooded for a long period of time, not a short period of time, but a long period of time. And again, something that a lot of people don't talk about is these plants that are used to living in those environments and are used to having those occasional floods, they can tolerate a small amount of hypoxia. In the short term, again, like remember what we were talking about, the rivers flooding and everything around those river banks is flooded, but it's only flooded for a short period of time before it kind of goes back into the original river form. That isn't going to be flooded, depending on the situation, but it's not going to be flooded for months or even years at a time. It will eventually retract back to where the river would have been. So you can see it's a short-term level of hypoxia and flood. Hypoxia, if you don't know, again, another Greek word is, so it's under, ipo is under, and oxia is kind of like oxygen. So it's kind of like the lower levels of kind of oxygen that are available to them that would happen if they're in a state of flooding for a short period of time. And let's bring this back into houseplants. Overwatering chronically is what causes the issue, not the occasional bit of overwatering. Remember what I said, the distinction that I've been saying in this whole section of the video is the short-term level of flooding. So yes, some of the plants, especially the ones that are adept and that are in environments that would be prone to flooding, will be okay for a short period of time. It's weeks or even months on end that can start causing some of these issues. And I'll put a little anecdote in here for a lot of people that maybe have seen friends or relatives that have literally had houseplants that you would never have imagined have survived, and they are sitting in boggy water because they're in a decorative pot, and all of that individual does, not because they are meaning harm to the plant, it's because they don't know any better, or they haven't thought about it too much, is, oh, it's Friday, I need to water again. No, it's Friday again, I need to water again. And then these plants end up sitting in a pool of water. And I've seen this, even my mother, who's had plants for years. At some point, she's just like, oh, don't forget to water my plants. And I'm just like, she'd have decorative pots. And a specific example might have been like a pothos, a golden pot, a huge golden pothos, or even for ficuses like this. And I went to water them. But before I did that, I'm just like, I don't know if she ever lifts these out. And I lifted the plant out. The smell that came out of that pot was insane. But it was sitting in liters of water. It was a big pot. That plant is still around, and at that point it had already been surviving for 10, 15, 20 years, and it still probably had another 10 years after that now. It's still alive, still going. So you would be surprised a lot of times. It's not that I'm encouraging you to do this, but I'm saying it happens more than you would think. And the plants can be quite resilient. So let's talk about herbivory and mechanical damage. And herbivory is just a word to signify that herbivores might be kind of munching on your plants. So it's kind of damage that might be happening to your plants. I can't lift any of my Monstera deliciosas because they're far too large, but here's a picture for you here with the split leaves. And let's touch mechanical damage first. So one of the theories, at least, with a lot of the plants that have got the split leaves, or even the fenestrations on their leaves, so either the splits or the holes within their leaves that happen naturally, and again, this is just the one theory, is that scientists are assuming it might be there from the plant that has evolved over hundreds of years in order to deal with strong gusts of wind that might be happening within their natural environment. If there's already splits on the leaves, they are less likely to rip when there's strong gusts of wind happening because the wind can go through it, especially if you think about something with like a very long paddly leaf. Did that snap the leaf? No. Again, mechanical damage. So the Philodendron esmeraldens here, very, very wide leaf, but it's also very thin. So this plant may have evolved the thinness and the longness of the leaves in order to be able to deal with that wind. Because if you'd imagine this leaf was as large as it was, and actually I took off a leaf earlier on, let me show you, this is the one that has had a lot of sun damage. There you go. Ta-da! Slightly on the red side, but again, this leaf is perfectly fine. It was just growing in a really awkward angle, so it needed to go, there's enough leaves on that plant now that it's fine. But you can kind of see something the size of this. Now, if this wasn't as thin and the wind was bashing up against it, you would imagine this would eventually rip and it would get splits and everything like that. Also, what you might imagine is the ruffles that are happening on this leaf as well. Some of that might be either for water runoff, or it might also be little kind of mini air channels, so it doesn't create so much friction if it's getting blasted by air. So that is one thing. These plants have evolved to be able to cope with their mechanical damages, sometimes proactively, and again, the example of a Monstera, they will create the mechanical damage themselves genetically, so the splits or the holes in the leaves, in order to better deal with their environment so they don't get further mechanical damage. And let's bring this into a bit of the herbivory now as well. So think about the fact that, and anybody who's had a pet, anybody who's got cats, who's always very kind of conscious of bringing in non-toxic houseplants, in the grand scheme of all the thousands of different forms of houseplants you can bring into your house, and if you look at anywhere online, those lists in the grand scheme of things are not that large. There is a good reason why they're the pet safe lists, that's what I mean. They're not as large as thousands of plants. They can be, but because sometimes you'll get like genuses that are a bit better at not being toxic to pets. But what that does mean is that all the others that are toxic to pests, guess what they're also very good at doing? Yes, they are very good at kind of deterring herbivores from munching on their leaves. One of the most common things that a lot of tropical plants and a lot of house plants have got is oxalates in their leaves. And actually, when you start going down that rabbit hole, and feel free to Google that a bit more, you'll realize that a lot more plants than you think have got oxalates. Even some plants that we will eat, whether they're tropical or not. So I'll give you an example of a tropical house plant, and it is, why am I forgetting now? It is the false shamrock, I think. Oh, I'll put the name at the top and put an image here so you can kind of see a very, very beautiful plant. Usually purpley leaves, the ones that we have for houseplants, and they'll open and close during the day and the night. And a lot of times it's one of the examples that people use as a tropical houseplant. You can chop some of the leaves and put them in salads and it gives you a bit of a lemony flavor. Guess what is providing that lemony flavor? Oxalates, but at a lower level. Some plants that we have in our environment, in our houses, have got high level of oxalates, the ones that are not safe for pets to be munching on, because it can give them upset stomachs, depending on the sensitivity of the animal as well, how small the animal is, or how large of an amount it is eaten. It could even cause death. In nature, where they are getting chewed on by animals, this is a great defense, because the animal will go, is this like, oh no, I nibbled on that plant's leaf recently and I've been sick and feeling horrible for days on end. I'm going to avoid that like the plague. Ta-da! Your plants are fighting back towards the herbivores by making themselves unpalatable. Yes, the oxalates might have other biological processes that are happening in the plant, and there is a debate on whether or not they have evolved to have the levels of oxalates that they have within them in order to deter herbivores only, or if they have the oxalates to deter herbivores and it's for another biological reason, or the oxalates are just a happy coincidence that happened and it's just like, oh, okay. So think about evolution, survival of the fittest. If a plant evolved to have oxalates for reason A, but actually, yes, it did help it achieve reason A, but reason B is, oh, unexpectedly, herbivores mean that they're munching me a bit more. Guess what plant is going to survive? The one that's not getting eaten by the herbivores. Evolution is survival of the fittest. The fittest are the ones that are not getting decimated by herbivores. And also think about certain plants, and I'm struggling a bit to think of plants that could have very strong, I'm looking at a begonia at the moment, some of the cane begonias. And give me any examples that you might have down below, because I'm blocking at the moment as well. Any houseplants that you know that grow leaves at an alarmingly quick rate. Guess what that means? Is that that plant, if there is mechanical damage, if there's trees falling on the plant in nature, if there's actually other animals chewing on its leaves, if it can produce leaves really, really quickly, it can survive. Because even if any of these things knock off half of its leaves, if it can replace most of the lost leaves in a very short period of time, it's as if nothing happened. Yes, that plant is going to be stressed, but they have evolved for this. So to bring it into really layman's terms, a split leaf in the jungle isn't something extraordinary. It's just another Tuesday. And how about we touch on the competition for light? And again, monsteras are a great example because they do something called scototropism. And again, I'll put a picture of a monstera here. And I've talked about this before. Scototropism, so skotadi is darkness in Greek, tropism or tropos is way. So it generally means that these plants, again, the example of a Monstera deliciosa, for example, will go towards the dark, not the light. And for a lot of people, it's just like, that seems counterintuitive. Plants need light to survive. Why would they go towards the darkness? Because they've evolved to realize that if they move towards darkness, if you think about it in a rainforest, if a monstera is growing happily here and this moss pole is a tree trunk, guess what's going to be happening because there's a tree trunk there, which means there's foliage over here. So if it goes towards a darker environment, it will eventually hit a tree trunk, which means it can then attach and it can start growing upwards towards better light. Ingenious, ingenious. Can you imagine how many hundreds, if not thousands of years that has taken for these plants to evolve towards that, to be able to recognize that if I go towards the darkness, eventually the payout will be that I will get higher light, rather than the obvious and easier option is, let me go towards the light that I might be perceiving. And then you get something as well that's called heteroblasty as well. So again, another big word, but this is more of a scientific video. Heteroblasty, blasty is something that, a blast is something that, I'm trying to think now. I don't know if it is a Greek word. I might correct myself, but I'll put it here. Hetero means something that's different. Plasti is to make. It might be an ancient Greek word, it might be a Latin word, but I will kind of put the distinction here. But heteroblasty in plants is when, and I'll give you an example here. So, and there's a reason why I'm holding this epipremnum here. So say this is the juvenile leaf, which is fully solid. These leaves are starting to become more mature leaves. Even though they are small, they are getting splits on their leaves. So heteroblasty in essence means more juvenile leaves look one way and more mature leaves look an entirely different way. Again, Monstera deliciosa, huge example. Fully solid, heart-shaped leaves. As it grows, it gets splits. A lot of the Monsteras will do this. A lot of philodendrons will do this. The bane of my life, there was the philodendron lupinum. Looks like a little baby Micans, and it's fuzzy, and it's got the red backs when it's juvenile. And then when it grows and becomes more mature, which is very difficult to do in a household environment, it loses the fuzziness, it gets leathery leaves, and it gets lobes. It changes form entirely. So heteroblasty. And again, that is because of competition for light. These plants, they're changing the structure of their leaves the more mature they're getting because, for instance, if they're epiphytic, they might be climbing up trees, so they're getting closer to the light. So these leaves now have got a different tasks than the leaves at the bottom. So again, let me use the example of the Monstera. Just keep using the Deliciosa as an example, but it ticks a lot of the boxes. It's such a well-evolved plant for its environment. So small, solid, heart-shaped leaves, a lot more surface to get light, the limited light that they're getting, especially if they're going towards the dark. And as they start climbing up, they will get the splits, the holes that we were talking about before. As I said, one of the theories is because they can handle the wind. The higher up they go on trees, the more likely they're going to be exposed to the winds. The other theory is if they're getting closer and closer to the light, but the lower leaves, because if these Monstera leaves were huge and intact, they would be shading themselves, which means the lower leaves would not be getting enough light. So some scientists think it's the wind, some scientists think it's because of the light, because the light can then filter through those splits on the leaves better to those lower leaves further down below. And the fact that these plants are even epiphytic in nature at all, so epi, the species, so upon nature or upon a plant, phyto is a plant, physi is nature. So epiphytic means upon a plant, which means that they have evolved in a way that, you know what, if we have a relationship with these plants, a lot of the tropical kind of aroids, they are not parasitic, not all of them, but they are not parasitic. They are not taking away from the tree that they're attaching to. They are just growing upon it in order to go higher. Can some plants that start as epiphytic become parasitic if they get big enough and they can then snap the host plant? Yes. But by their nature, they are not inherently parasitic. So they're not there living off the plant itself. I think a really good example of a parasitic plant, which a lot of people might not realize, is mistletoe. I didn't realize until very recent years that mistletoe is a parasitic plant. So it will grow upon a tree, but it will actually use the tree for nutrition, I think, not just for support. Epiphytic plants, by and large, will not do that because they recognize that they need the tree to survive in order to give them the best chance of survival. So hopefully all of this combined is going to help us all start to shift our psychology and our mind frame from fragile to adapted for resilience when it comes to a lot of our plants in our collections, in our homes. For most house plants, death is usually the kind of result of chronic mismatch of conditions. So for example, if I kept watering this all the time, even in winter, I am mismatching the conditions that this plant is evolutionary adapted to dealing with. And you can see throughout this video I was giving you some examples, like talking about the ones that were in the floodplains as well. They can handle some flooding for a short period of time. But even that slightly longer, that nuance of it being a longer period of time could still cause it harm. Yes, it is okay with it for a short period of time. It's not an aquatic plant. So that is something that we need to always remember, that they are highly adaptable for their conditions as long as we don't abuse that adaptability, because they can only take so much. They're only adapted to deal with it for so much in their environments. If they were in harsher environments and they had to deal with that for a longer period of time, they would be evolutionary adapted to deal with it for a longer period of time. Does that make sense? And evolution by its nature favors resilience. Remember what I was talking about before? This is the saying that a lot of people have been saying for a very long time. Evolution is survival of the fittest. So it means that the more resilient the plant is to its environmental stresses, the more likely is that this will be the plant or version of this plant that will survive, and the rest will fall back, which means if only the plants that have these traits, that have developed these traits, are the ones that survive and everything else doesn't, by default, that is the new line or version of this plant that will go on to survive for however long more until a new stress comes in, and then the next survival of the fittest will happen. But ultimately, and I'd be really interested to hear your thoughts, confidence when it comes to growing plants comes with the understanding of this adaptation, comes with the understanding of, oh, okay, this makes sense. If this plant is like this, it means it's adapted in that way. And this is the thing that comes with time. You might have been doing it subconsciously without realizing, by looking at something with thicker leaves and just going, oh, I can leave those thicker leaf plants for a bit longer without watering or between waterings, and they will be completely fine. You've made the connection, you've maybe not made the connection as to why the plants are the way that they are and why they can handle it. But that is why it's important a lot of the time for all of us to do some extra research, especially if it's a plant that you've never heard of before. And I know a lot of people, when they were following the trends of the plants, they were constantly wanting other information from other people that were growing the plants, because they're just like, well, this is tricky and I'm finding this difficult, and how are other people dealing with it? Where actually a lot of the times, if you are not following a trend and you're buying a plant that nobody has, your only option at that point is to do some research yourself from like scientists to see where it might be growing naturally and start to make some connections. So, okay, it's growing here, it floods quite often, the temperature's like this for most of the year, it gets this much rainfall, it has this much kind of level of humidity, it has strong winds, it's growing on the ground level, so it's probably, do you see what I mean? You can start making those connections and go, oh, this plant has likely evolved this tactic, this tactic, this tactic. So it, by default, it means that if I do A, B, and C, I should be replicating its conditions, which means it should not only be able to handle it, but also thrive on it as well. And ultimately, and I think this is what I'm going to leave you with, is that we need to start thinking about care isn't about controlling our plants. It's about working with the biology of our plants. That's where you get the best care, at least in my humblest of opinions. But yes, hopefully you've enjoyed. Hopefully I shall see you here soon. And I truly, truly hope that you have a great rest of your day. Thanks. Bye.